Whitney from Knitronics, and I'm back here continuing with my video tutorial series on how to get started with FPGA development, specifically in the Xilinx toolset with Vivado and Vitis 2021.1 using the RDZ7 from Digilent. In the last few series, we've covered how to install Vivado and Vitis, how to set up a base Vivado design specifically for an FPGA development board of your choice, the RDZ7 in my case, and then we actually went through the overall compilation steps of any FPGA design, which is synthesis, place and route, and bitstream generation. So we're picking up after the bitstream generation to transition to the embedded software side of things. So not all FPGAs need embedded software in particular. However, it's very common when you're using something like a system on a chip, which is technically what the Zinc chip is, in that it has a full-on ARM core processing system instantiated with it, or if you've chosen to implement a soft processor within your FPGA logic, such as the Microblaze, the RISC-V, or any of those other soft processor CPUs that are available. So because we have the Zinc and we have that ARM core instantiated within it, physically that's there, we're gonna look at how to then take our design from Vivado, that's our hardware design, pull that into Vitis, which is our software platform development, and actually run a little bit of C code, specifically just a simple little hello world. So we're gonna come into Vivado, and the first thing to do is we need to export our hardware platform in a way that Vitis can read it in. So we're going to go to File and Export, Export Hardware, and we're gonna walk through these screens. So next, we want to start with our overall design that has been implemented and our bitstream and generated. We want that included. We don't want our pre-synthesis design. We want the full design. So we'll click Include Bitstream and Next. By default, it wants to name the hardware platform the same as your block design. Well, the same as your top-level wrapper name, which stems from your block design name. You can change this if you'd like, no big deal. By default, it wants to export to the top-level directory of the Vivado project itself, which is where I like to leave it. And the hardware platform exports as a .xsa file, which that's XSA file type is something that is unique to Xilinx. It's the Xilinx package compression file type, I think. It's their custom thing. So an XSA file is not something you're gonna see with other tools, just so you know. So we're gonna hit Next, and then we just get a nice little summary of what operation's about to happen. We click Finish. So we're just gonna wait for that to complete. And now we're ready to launch into Vitis. So we can either come back to a terminal and source the Vitis settings script the same way we source the Vivado settings script and launch it individually, or we can come up and launch it directly from Vivado. So under Tools, there's an option that says Launch Vitis IDE. So we're gonna go ahead and do that. Because this is the first time that I've launched this version of Vitis 2021.1, you'll notice that everything's blank. It just wants to create a blank workspace in my home folder. And you can have your Vitis workspace live anywhere you want. Personally, for my organizational habits and just to keep things straight in my mind, I do like to put my Vitis workspace within the top-level Vivado project directory, just because I'm basing that Vitis workspace on that particular hardware design. So what I'll do is I'll navigate to my Vivado top-level design, so RDZ7 2021.1. And then within that, I like to add a new folder and just title it Vitis Workspace. And then it's within this folder that I point my Vitis workspace to. To me, it just keeps it clean. That way I know which Vitis workspace goes to which Vivado base hardware design. So we'll go ahead and click Launch, give that a moment to launch.
A few moments later.
Now, if you've been a long-time user of the Xilinx toolsets and you used the Xilinx tools back when it was SDK instead of Vitis, You'll remember that SDK would actually automatically pull in your hardware platform and go ahead and configure it a little bit. Vitis is a little bit different. That action doesn't happen. The workspace that opens after you hit launch is totally blank. So the first thing we need to do is create a platform project. So the platform project is the project that actually pulls in that hardware platform, creates the board support package or BSP based off of that, and lets you target this. It's kind of that layer between the hardware and the actual embedded application that we're going to create later. So create platform project, and we'll go ahead and name that. So RDZ7 platform. You name it whatever. And then the XSA file, we'll need to browse to that. By default, there's some provided XSA platforms from Xilinx for their common dev boards like the ZC702 or the ZC102, but we need to navigate to the XSA we just exported from Vivado. So we're gonna go back to our Vivado top level folder where that wrapper.xsa is, and hit open. And you notice it'll pull that in, start to auto detect things. It'll notice for operating system, we're gonna do standalone. So it's just a plain bare metal C application. We're not trying to do RTOS or Linux right now. The target processor, so if you don't already know, the ARM core in the Zinc 7000 series for the RDZ7 is a dual core. So we can choose which ARM core we want to target our applications on. So we're going to just choose the default core 0. And then we also want to automatically generate the boot components when we create this. So like our first stage bootloader and whatnot. And all that's checked by default. So we'll just go ahead and click finish and let Vitis go ahead and generate everything, and there we go. So you notice when it first comes in, it hasn't been compiled yet, so that's why it says out of date. So just as a quick house cleaning thing, we'll just do Control B to go ahead and build it, get that first build out of the way. That way it's ready and up to date. And again, because this isn't a super complex design, the build doesn't take very long. But just like I mentioned in the previous tutorial, the more complex your hardware gets, the bigger the design, the more fabric space it consumes. Some of these builds are definitely going to start to take on the longer side. So just know that there's a direct correlation there. Now that we have our board support package and our base hardware laid out here in the Vitis software development kit, or IDE, we can go ahead and create our bare metal application. So from the new menu here, we'll click Application Project. And this is just a little welcome page that pops up the first time you create a new application. If you want to, and it kind of just explains where the application project goes in the scheme here, and just kind of mentioning you have to have a platform project to be in between your application and the actual processor. So we've got that. If you don't want to see this every single time, you can check this little box to skip welcome page next time. And then next, so when you're creating your application project, it is possible to have multiple platform projects within the same Vitis workspace. In this case, we only have the one, so it only shows that there's only the one in the list here. And again, if we wanted to, we could create a new hardware platform from one of the predefined XSA files. But we're going to choose our custom one that we just created in the last step with the platform project and click next. So we're going to name our application Hello RDZ7 and let it create a new system project. Again, it's just mentioning we're targeting the ARM Core 0 processor here and the associated application. Hit next. And we'll do standalone again. Standalone's kind of the only option for domain here because we don't have the components for like a Linux OS or an RTOS right now. And click next. And what that's gonna do is then bring up, Vitis has a certain set of application templates available for you to use. So for instance, if you you can there is a blank option, so you can do everything from scratch yourself. Or if you're wanting to go ahead and there's the lightweight IP Echo server, our basic Hello World, a Zinc first stage bootloader. They're very handy if that's the type of application you're already gonna create. It's nice to kind of start with that and then just make your mods. So we're gonna go ahead and do our Hello World in C. That's selected by default, so I'll go ahead and click Finish. And we're gonna give Vitis a moment to go ahead and generate that new application project. Taking a look at and expanding under, you'll see we've got our platform project here at the top, and then our application project here at the bottom in the Explorer window. So the Explorer window does sort everything just by alphabetical order, so it won't necessarily always be the platform project at the top followed by your application projects, just however you name it, it'll order it in alphabetical order. So under the actual application project here, you'll notice we have our source code, and that's where our actual hello world.c is with our main function. So you'll notice we've got just one single print here of hello world. What I like to do, just before I do a debug run and actually run it, I like to put this in a loop. That way I can actually catch it and see the output. So I'm just gonna do a simple while one infinite loop, and put our hello world in here, followed by a for. I put a for loop in here for a delay, simple, quick and dirty delay. I is less than probably, I think we're running at 50 megahertz, so we could do, let's see, 1, 2, 3, 10,000 clock cycles should be enough for a reasonable delay. And I plus plus. I'm doing a simple for loop here instead of an actual delay, so I don't have to include any other libraries or remember where that's included, just for ease and quickness of demoing here. So I'll go ahead and save that file and then build the application project. Oh, what are we mad about? Do I have a syntax? Oh, forgot to put INTI. Go ahead and build. So as you can see, there's our simple hello world infinite loop application now. So we're ready to see how this runs on the RDZ7. So we're going to go ahead and plug in. We've got, you'll notice our programming UART port is labeled here in our USB host. So we'll go ahead and plug into that. And because we're just running a simple little bare metal application, I don't need external power. Once you get into the more power intensive things, like if you're running an embedded Linux image or an RTOS image, like off an SD card, powering it off the USB won't quite be enough. You'll need the external power, but for now, we're just doing a simple debug on a bare metal hello world, so we'll go ahead and plug that into our computer. Now, so what we're gonna do is we're gonna launch a debug run of our application here, and I'm gonna show you how to actually get it up and going to where you can step through your application, set breakpoints, or you can just go ahead and let it run. So, on the name of the application here, we're gonna right click and select Debug As, Launch on Hardware, our single application debug. And when we click on that, Vitis will click over to our debug view. Start by programming the bitstream onto the FPGA and then launching into it, and you'll notice it'll come straight in and automatically set a breakpoint for you here at a NIP platform. We have our regular options of resume, step into, step over, step out of, so we'll go ahead and step next. The nice thing about Vitis is it does have a built-in serial terminal in it. You can still use, if you prefer to use PuTTY or TerraTerm, you can totally use those instead. I really like to use the built-in serial terminal in Vitis when I'm in debug mode, just keeps it all nice in one window, one thing to look at. And that automatically pops up when you're in the debug mode. So I'm gonna go ahead and click the little plus button here. and you'll see the USB ports available. So I'm going to our RD is shown up on USB 1. The baud rate, since it is a Zinc UART, the default baud rate is always 115/200, and then the rest you can leave as your default here and click OK. So now when I click over this print statement, you'll see our Hello World printout here in the Vitis serial terminal. And since I don't want to hit step over 10,000 times, I'm just going to go ahead and hit resume. And you'll see now we've got our infinite loop Hello World printing out every few milliseconds, it looks like, whatever 10,000 cycles of a 50 megahertz clock is. And you can always hit pause and then continue to step through from there. It looks like we caught it in the middle of writing to the UART port. So if I keep clicking, and you can see I'm actually spitting out each character out of the UART buffer here. And then it should throw me back to our main code here where it's in the middle of our for loop again. There you have it. That is actually creating your embedded C application for starting your software development on your FPGA board if you have a CPU somewhere on your FPGA design that you're actually targeting. Well, and that covers it for the software development portion of your FPGA design. If you have some sort of CPU in your FPGA, whether that be the actual ARM core that's instantiated in a Zinc, or if you have a soft core processor like the Microblaze in there. But I only specify that just to make you aware that not all FPGA designs will necessitate this software component. It is possible to have an FPGA design that's purely within your HDL code, and your bitstream generation in Vivado would technically be your last step. So definitely make sure you understand the difference between just having your design in the HDL code versus what's running on an actual CPU. Well, that's all for this video, so keep an eye out for the next part in this series, and I'll catch you next time. Bye!